Hey everyone, we are Ben and James. We work at Infinity Works, which is a tech consultancy. And so our presentation today is going to be on getting to know a cloud engineer. So yeah, just going through, we're basically going to go over our backgrounds, what it actually is a cloud engineer, what cloud infrastructure is, what full stack engineering is, and kind of our day-to-day in a nutshell. So we will kick off with our background. Ben, I don't know if you want to go first.
Yeah, sure. So I've been in the tech industry for quite a long time. I came into the tech industry through a fairly traditional route, which was to do a 3-year computer science degree. Graduated in 2002 and have been working in tech pretty much ever since, and have seen the kind of transition to the cloud from the good old days where we had to build our own servers and provision our own infrastructure, all the way to now where we've got the amazing services provided by people like Amazon and Google and Microsoft with these awesome clouds.
And yeah, my background is completely different. I studied history, which obviously has been very useful for my job today. I worked in advertising previously in another life, and then I basically decided on a career change. So I kind of was self-taught, found a load of really good resources online and communities in London that I kind of went to meetups and things like that. And then, oh, I should really switch off my email. Basically, yeah, so decided on a career change. And yeah, taught myself to code and then started working at a consultancy prior to Infinity Works, and then joined Infinity Works, I think 3 or 4 months ago. So yeah, just to highlight that, you know, basically everyone they work with has a different background. Doesn't really matter if you've done like a computer science degree or not. Yeah, there are people who have just gone different routes to becoming cloud engineers. It's just thought it was good insight. And here's our meme, which I can't really remember the exact relevance of it, except that this is the effect that cloud computing will have on you once you learn about it. So yeah, moving on to what a cloud engineer is. And again, we have again another irrelevant meme. It's meant to say cloud engineer, but we thought it was a funny image. But Ben, I don't know if you want to give a quick summary.
Yeah, sure. So as a cloud engineer, I kind of feel like we might somewhat contradict what Kimberly was saying earlier about all jobs being a software engineer. We are primarily software engineers, but as a cloud engineer, you get a lot more responsibility than just writing the code. Can you do that? That's quite a traditional approach to software engineering. Is a software engineer will write the code, and an ops team or an operations team or an IT team will manage all of the infrastructure that code runs on. We'll talk about what is infrastructure in a minute. But as a cloud engineer, you're essentially responsible for provisioning and running and maintaining the infrastructure that your code runs on. It gives you a lot more freedom and a lot more independence as a software engineer. If you think there's some cool new thing that you want to build, back in the olden days, you would need to ask someone for thousands of pounds for a server and take months and months to provision it. Whereas now with the cloud, we can, with a few clicks or a few lines of code, spin up some pretty cool infrastructure and experiment.
Yeah, so basically, you know, the next 2 slides are talking about the cloud infrastructure side, and then we'll go on to the kind of the more full stack engineering side, which I guess traditionally kind of people tend to separate the two, but yeah, our role kind of encompasses both parts of that. So yeah, moving on to cloud infrastructure. So our funny meme for this is, yeah, I mean, so kind of the basics of I don't know how much experience people have with the cloud or knowledge of it, but we'll just go over kind of like a brief overview of it. So I mean, as this meme kind of suggests, you are basically just using someone else's computer in that, you know, traditionally you would have, you know, to host your web application, you would have built your own server, had your own hardware, and use that to basically serve traffic to people around the world. Basically, what cloud infrastructure does is it provides a way for you to provision these servers without actually having to own the hardware yourself. So instead of me having to go out, order all the different hardware, set up my server, run my application from there, I can go to a cloud service and basically say, hey, I want this storage, hey, I want this computing power, and you can instantly provision that infrastructure. So you have services that allow you to pay as you go. You can scale. So instead of having to, with the traditional way of hosting your own servers, you have to keep building new servers, and it's quite a slow process. Instead, you can basically scale as quickly as you want to. Ben, I don't know if you want to add anything to that.
Yeah. So back in the day, you would kind of have to predict how much traffic. We're talking a lot about web servers here, I guess, which is something we should probably point out. But you kind of had to predict how much traffic your website or your service was going to serve, and build infrastructure to cope up to that point. You essentially had to over provision and spend a lot of money to make sure you could serve that traffic. And if you did exceed that, if the traffic exceeded what you could serve, again, you're in a really slow process of buying a server, setting it up, getting it in the rack. Some places would kind of do that for you, but you still had to go through a procurement cycle, and it was really expensive. With the cloud, essentially, there's so much computing power available in these clouds that you can instantly respond to pretty much any traffic, any level of traffic. It's a bit more complicated than that. It's not easy, but the computing power is there available for you, and you only pay for what you use. If you have a giant spike for something like Black Friday, you can spin up the new infrastructure for November and December, and then turn it all back down again, and you've just paid for what you've used.
Yeah, and what's pretty cool. So I mean, these are the main cloud infrastructure providers. So AWS, Microsoft Azure, and Google Cloud Platform. And what's really cool is, I guess this kind of relates to what we do, is you can basically build infrastructure as code. So all these services allow you to basically write out code instructions for what infrastructure you need. So I might go, I need this amount of I need this many servers to be running. I can just write out in code, and you have a record of all the infrastructure that you have, and basically allows you to do version control with your infrastructure. You have a history of all the infrastructure to be provisioned, and so it allows you to have the same benefits as you would have from traditional coding a web application. You can see the history. People can make pull requests to make changes to infrastructure, and you have that record, which just allows you to keep track of your infrastructure that much more easily.
It also allows you to recreate it as well. So things go wrong, servers break. I don't know if everyone noticed that not that long ago there was a huge fire in a data center in Europe, which presumably took out a huge number of companies' servers. If you've got infrastructure as code, you can run that code in a different data center and recreate everything that you had set up, exactly the same as every time you rerun it. Obviously, well, not obviously, it's really difficult to do that back in the olden days when each server was manually set up by someone logging onto that server and clicking buttons and configuring things. There's something else I was going to talk about around clouds. Oh yeah, so we've talked a lot about servers, and everything ultimately does run on a server. But what these clouds provide is something called managed services, and that's kind of the modern way a cloud engineer, well, not always, but would try to run their services. If we're provisioning servers, even in the cloud, we've still got to do a lot of management of that server. We've got to make sure we install updates, make sure it's got the right tools installed. Say for example, we wanted a database, we could spin up a server in AWS, install whatever database technology you want on it, make sure the operating system is always patched, make sure the database is always patched. But what we can actually do these days is say, just give me a database, and these cloud providers will create a database for you and deal with all of that kind of patching and make sure you're always on the latest version and always secure, which is pretty cool and saves a lot of time and effort.
So I hope we hit someone typing or something.
Someone's typing, yeah. I thought it was you, James. You're responding to messages.
Yeah, I'll let Ben talk. I'll do some chat.
Get some work done.
Yeah. Cool. So yeah, now kind of having covered cloud infrastructure, we're going to go into stack engineering and what kind of that means in a nutshell. So again, a couple more memes, although I've lost my notes. But yeah, so essentially, full stack engineering, I mean, traditionally it means front and back end engineers, like kind of combined to one. But now it kind of, is this kind of catch-all for an engineer that kind of can in theory cover most things. But I mean, looking at it in terms of the traditional sense, so I mean, front end engineering, you kind of classify as the client facing end. So you take a website or a mobile app, and as a user of that app, you're kind of interfacing with this front end, which is kind of like the presentational layer. So it shows you the presentation of the app. Whereas the back end, you'd kind of distinguish as sort of dealing with the data and the logic that will populate that front end, of which both require different skills. But in our role as a cloud engineer, we kind of deal with both, and part of that again is also going into architecting applications. So we'll be considering both how the front end will work with the back end. But I don't know if you had anything to add around that.
Yeah, sure. So yeah, as a full stack engineer, as James says, you're kind of responsible for the whole product from start to finish. You'll get involved in the new word is ideation about what the product's going to do, how it's going to do it, how it's going to be built. As full stack engineers, you also get involved in so how it's going to be built. There's this thing called CI/CD, which is continuous integration, which effectively is every time we make a change to the code, we commit that to a source code repository, and it builds everything, runs all the tests, and kind of making that work is a job in itself, of effectively writing a bit more code to build the code. And we're, as full stack engineers, you're also kind of responsible for the application after it's been released. You're not just building it and testing it, but you're monitoring it once it's out in the wild and people are using it, and you're kind of making sure that it's behaving and it's responding to the amount of traffic in a sensible sort of time frame and things like that. You're responsible for the whole app from start to finish.
Yep. And again, this kind of features into also the infrastructure as code. Again, with CI/CD, you're kind of coding how the deployment process. So again, like as a kind of a full stack cloud engineer, you're essentially writing code for every step of the way, in terms of from the start of creating your app to releasing it. So that entire process will be coding and committing to a repository, which will trigger these build processes that will provision infrastructure and deploy our code within that infrastructure. So yeah, then moving on to our day-to-day. Let me just check out my notes. Yeah, so this is our, so I mean, this slide, again, these aren't particularly relevant to what we do, but we just thought it was funny. But yeah, I mean, our day-to-day isn't as chaotic as things being on fire. The kind of routine that we have is, so we kind of follow agile practices, which we'll get into in more detail, but part of that is having a stand up every morning, where we give our updates on what we've been working the day before, what we're working on today, and if there are any kind of blockers or anything like that, just to make the rest of the team aware, because often it's good to share contexts, and other team members might have insight into something, or they might be able to help you get unblocked. Say there's some sort of process that's holding up the piece of work that you're working on, and we tend to have a board which essentially has all the different work items that we need to get through. Say we're working on a feature, we'll have a list of tickets which will have the feature broken down. So yeah, we'll pick up a ticket, and essentially working on those tickets involves doing a little bit of investigation to the requirements. Usually there will be the requirements on the ticket, but sometimes you kind of have to, there might be certain points that need to be clarified. So you talk to the various stakeholders or users or whoever's involved in that ticket. And then essentially what we're doing is we're writing the code, we're writing tests for it. So different types of tests, kind of unit tests, integration tests, end-to-end tests. We're configuring any infrastructure that we might need for that feature. So yeah, I mean, like, obviously it's dependent on the feature, but we might need to provision some, for instance, like an SQS queue, or maybe I won't go into too much detail about the ins and outs, just in case the context isn't that clear. But there might be different types of infrastructure we need for a feature that we're building. And another part of it is also building monitors. So again, this is something we do with code, but we'll use a service. So the one we're using at the moment is called DaytoDay. And what we do is we build monitors that they'll monitor the status of, say, the applications that we've built, because essentially we want to make sure that nothing is going wrong. And if something is going wrong, we want these monitors to alert us of that so that we can react quickly and basically fix anything that's broken. So these monitors are really important because you have thousands of users accessing a website, say, per day, possibly more than that, and you essentially want to catch these errors quickly because they could have an impact on, say, a business. So that's really important. Ben, I don't know if you want to.
Yeah, sure. I can add a little bit to that. So, so you kind of mentioned thousands of users a day. This is a bit of a brag, but the client we're working on had an advert on the TV during the Harry and Meghan Oprah Winfrey interview, and they were getting tens of thousands of requests a second. So it's really important to kind of monitor and make sure things are working. But I thought that's quite a cool little fact about the client. I don't think it's a secret that we're working on Cinch. So if anyone's heard of them, that's who we're working on. Yeah, so James, as you've talked about kind of like the day-to-day work. Another thing that we do a lot, which I think might be interesting, is we kind of that's our day-to-day. We write code, we work on tickets, we provision infrastructure, but there's loads of other things that go along, alongside of that. We do a lot of work where we have what we call guilds or communities of practice, which get together every week or every couple of weeks, where we'll talk about particular topics that we think are affecting the teams. So, for example, we've got a guild, a backend guild, where we'll all get together and say, "Oh, I'm having these problems in the backend. Like, this is an approach I've taken to solve it," and sharing ideas and sharing solutions with each other, which we do a lot. I guess that probably is the only thing I think I could think to add to. We write code and talk about it a lot.
Yeah. I mean, part of those discussions, I mean, yeah, so we have these kind of, communities of practice or guilds, where, basically it's kind of a wider forum for people to discuss things. I mean, within our squad, apart from just, going off and writing code, we'll have a lot of technical discussions amongst the team. And kind of at the beginning of maybe implementing a big feature, we will be discussing architectural decisions. So, before, say we want to implement some sort of feature, before we go about, we don't just dive in straight into the code. We kind of have to think about the wider architecture and the wider implications. So we'll want to discuss, we'll often be drawing diagrams initially to set out some ideas of, okay, for this system, we're going to need, we're going to need a database, obviously. We're going to need functions that execute requests, and we kind of plot it all out. And we kind of see as the kind of the bigger picture what we need to provision, what services will be communicating with what other services, and those diagrams change over time. That's the thing about Agile, is that we build based on our initial idea, but once we start building, other things will come up. We'll notice that we have other requirements that need to be met. or potentially we would have missed something. One service interacts with our service in a way we weren't expecting, so we kind of have to adapt. And it's kind of this iterative process where we'll constantly be communicating the plan for building this feature, but over time that changes, and it also changes depending on business requirements. So we can release something, we can test it out with real users, and based on feedback from those users, we can then change that feature. So that's just something that's really cool. It's not just a question of our job is just code, deploy, that's it. It's very much like come up with ideas, work out a plan, come up with an architecture plan, build, and then get feedback, and then continue developing off that. So that, I just wanted to mention that we do have these wider technical discussions, architectural decisions. And another cool thing that we do just in our day-to-day is we'll pair together as well. So we kind of switch it up where sometimes, if we've got a lot of different tickets that need to be done at the same time, we'll kind of go off and work on it. Maybe, one person will code on one thing, one person will code another. But often it's really, really helpful to pair on something, because essentially you've got two people tackling the same problem. And, that means you're going to have two sets of eyes that are going to see more than maybe one person by themselves. So, I might have missed something, and if I'm coding with Ben will go, what about this? And I'll go, yep, completely right. Can't believe I missed that. And vice versa. And it just means that code quality as well ends up being better, because, I could go off and code something and, completely I could have completely missed something. And then, I make a pull request and someone goes, oh, did you consider this? And then essentially you have to go back and rework it, whereas when you're pairing with someone, it's just really helpful to get that instant feedback. So just like another small point about our day-to-day.
Yeah, that's one of the cool things about going back a couple of things about what you said. Is the cool thing about being a cloud engineer is that we can write a front end, write a back end, set up all the infrastructure that we need to run it all, and essentially deliver a whole product, from start to finish. It's quite cool to deliver something like that. Whereas in the past, you would have needed, I'm not saying that we don't need a team. We obviously do work in a team, but you would have had all these different disciplines. It would have had all different sort of timelines. I'm busy doing this. I can't help you out on the UI. I'm busy doing this. Your server's not ready. And so we can actually just, using the cloud, be responsible for everything, not have to wait for infrastructure and deploy it and get it in front of users and see that making a difference, or see whether our idea was a good one or a bad one.
Yeah, so it frees you up to basically to remove blockers that in the past traditionally, because of that separation, sometimes were quite painful, because you'd be waiting on other teams. So that is our sales pitch to becoming a cloud engineer. And that's kind of the end of our presentation. So I don't know if we want to.
We need the end slide.
Yeah, we didn't actually have an end slide. We just have this on flames meme. But yeah,
screen share so they can look at our faces.
Yeah, I'll get rid of screen share. Voila.
The question is, what programming languages do we use to manage infrastructure? So at the moment, we're using, the client we're working on uses Amazon Web Services, and Amazon Web Services has a tool called CloudFormation. I know that's not a programming language, but CloudFormation can be programmed in a couple of languages, and we're using TypeScript. But you can use YAML, you could use plain JavaScript. I think, go on, James, there's a few others probably.
Yeah, well, I was going to say that in terms of tooling, so yeah, I mean, I guess if we're talking strictly language, we use TypeScript, but in terms of the tooling, so via the serverless framework, which will then we'll write it within the serverless syntax using TypeScript, that converts it into CloudFormation. But I mean, other tools that you can use are things like Terraform. I mean, within the CDK is the Amazon one. I mean, that's essentially the CloudFormation syntax. But yeah, Terraform is another tool that I've used in the past, which is really good for being able to provision any type of infrastructure on different services. So yeah, there's a multitude of tools you can use. But yeah, YAML, going strictly language, you can use like YAML or TypeScript or. I can't think of.
There's a dead easy question, which is, do you use CI/CD? Yes. So everywhere I've worked for the last 7 or 8 years has used CI/CD. I know it's not necessarily got 100% adoption, but as consultancy, we would only recommend using CI/CD. I think if you're not using CI/CD, you're way behind the curve and probably missing out on some competitive advantage. Do you want to grab one, James? There's quite a few coming through.
Yeah, I'm gonna go back to the top. So this is a bit more general question, but you mentioned using tooling like Datadog. What's your process of choosing what tooling to use? There's a sea of choices out there, and I get a bit overwhelmed. Yeah, I mean, there are just too many options. I mean, so with something like Datadog, I mean, we weren't involved in that that decision. So our client uses Datadog. I'm not sure if InfinityWorks would have suggested that initially, because we've been basically working with Cinch for quite a long time. So potentially that would have been suggested right at the start. But essentially, I mean, in terms of, say, how consultancies will suggest tools, often there'll be some research done into a couple of options that seem like the best for the client need. So again, it's often about like assessing what the client need is, researching what potential options are good and well tested, mature, and seem like they fit the purpose. And then from there, you would kind of write a proposal as to the benefits and disadvantages of each. Cost can also be a factor, depending on, yeah, obviously clients are concerned about costs, as most people are. So that can also be another factor. And again, sometimes, you know, it might be about experience. So a client may have engineers who have had experience with a certain tool that they're big fans of. So that can factor into it, which I don't think necessarily answers your question that helpfully, but it's just to say that there's no straight answer of how you choose. It really is dependent on research and the requirements that you need for that tool.
Yeah, something which might not be, I don't know, one of my thoughts on this, like you're right, James, if there's two products that are similarly priced that have similar feature sets that cover all the use cases, like just choose one. Once you've done all that analysis and there's two that are the same, you can kind of get a bit stuck on like choosing which one's the best. What I try and do is choose one, but don't get totally tied into it, so that you can change your mind if it turns out a better one comes along. And one of the big factors about choosing a tool as consultants would be like how easily can we integrate it with CI/CD and infrastructure as code, so that we can change it easier.
Yeah.
So there's loads coming in. I'm gonna go through the next one. So what does testing look like on the cloud? Manual and automated. Absolutely manual and automated. You know, again, the modern software engineer tries to automate as much testing as you can, but I still think there's definitely some value in a sort of thin layer of manual testing. Obviously, what's it called? Exploratory testing is pretty important as well. So yeah, mostly automated, but never ruling out some manual testing.
Yeah, I mean, like we'll write tests as much as we can. But yeah, again, sometimes, you know, you just want to deploy a stack, hit an endpoint manually, or, you know, if you're on the front end, often writing end-to-end tests is more pain than it's worth. So sometimes you're just going to be manually testing things. But again, as much as possible, we'll be writing automated tests.
I guess one sort of thing to think about in that regard as well is like what is it that you're writing? Are you writing something you're going to keep for a long time? Because actually spending a long time automating all the testing of that actually is just money wasted. If you're just doing a bit of an experiment to test an idea out, like maybe don't go full out on it, creating this amazing thing that's covered by 100% tests. Just do enough to see whether your idea works or not.
So next one, there is currently a move towards low-code, no-code applications for building web apps. Do you see this trend extending to cloud engineering? I mean, so I think there will be. I mean, again, like with the cloud, at a click of a button, you don't have to do infrastructure as code. You can provision stuff within for instance, we use AWS currently for our current client, and you can click of a button, provision different infrastructure. And yeah, I mean, in the same way that you can, yeah, build websites without much code, you can do the same with infrastructure. I think though that the value of having infrastructure as code, as Ben was saying, you can easily replicate it. You have version control, and it allows you just a lot more customization. I guess that's kind of the argument against, well, not against, but but no code applications versus code applications. You just have a lot more flexibility, I think. So yeah, I mean, the trend, you can already provision infrastructure with little to no code. If that answers the question.
Yeah. Someone is asking about personal project ideas that would get a full feel of how to use cloud tools. So for me, any personal project, I've got to be passionate about it. I'm rubbish at doing personal projects because I get bored of them, because I really want to do a personal project to learn a specific thing, but because my heart's not in it and I'm not passionate about solving the problem that I'm trying to solve, I'm just interested in learning a few tools, I essentially abandon most of them. So my advice, if you want a personal project, is make it something that make the problem that you're solving be something you're passionate about, and then the tools, you just use whatever tools are right, or that you feel like learning.
Yeah, I mean, but basically you just want to have essentially you want to build a full stack project. So you just need you can build a web app that has some sort of connects to a service that connects to a database, and then from there you can use any cloud platform to build that. And what's really cool is there are loads of different ways you can do it. So I could say to you, you could build it as a serverless architecture, or you could build it as a traditional having a server controller type setup, and you can use the cloud to do that. But essentially any project that has that full stack overview, because you want to be able to provision infrastructure that supports your front end. So that's kind of my advice in a nutshell.
So, go on, James. Go.
I was going to read the next question.
Yeah,
what do you need to know for applying as a cloud developer? What do you recommend if we want to move from front-end role to cloud developer? Good question. I mean, there are just so many things to I think the main thing is to know that you're never going to know everything. So don't feel as if you do have to learn everything about the cloud, about engineering, like full stack engineering. I think, again, it's always useful to, so say you're coming from a front end role. I would try dipping into again building a full stack application. It honestly doesn't have to be complicated at all. Just a really basic, just something that connects to a database and just pushes that data through to your front end. And then from there, after you kind of got that foundation, I would then look into cloud tools that would help with that. Again, you're not going to learn everything. There are a ridiculous amount of cloud services. I didn't know a lot of them. I recently did an AWS certification, which I was doing all the tutorials and things, and then I was like, I'd never even heard of some of the services, and a lot of them, like in your day-to-day, you won't necessarily use. So yeah, again, don't worry when you see all these different services that you have. Just dip your toes in. I'm sure there are a few kind of good YouTube or Udemy courses that can kind of help you with that. But yeah, I would start off basic and then incorporate a full stack project with the cloud and just see what you can build. And inevitably you're going to get stuck. That happens with us even now. We'll be like, okay, we're going to try and use this service, and then essentially you're always learning as a cloud engineer. So don't feel as if you're kind of a bit overwhelmed. It's completely natural. But yeah, it's just taking it bit by bit.
If you want to move role, I think like a non-technical answer to that is like ask for support from your company. It's companies want to hold on to people, especially if you're already in a front end role. You presumably know a product, you know a company, you valued there, and if you say I want to learn some cloud engineering, I want to, part of that is doing some of the backend coding, part of that's getting into the infrastructure. You need to let someone know that that's kind of what you want to do, and ask them to give you an opportunity to do it. Because actually, my favorite way of learning anything is to do it on the job. I kind of like to be thrown in at the deep end. I know that's not for everyone, and I've got a fair bit of experience. But if you were to ask your company, this is what I want to do, support me in doing it, like get me to work alongside, like we were talking about earlier, pairing, work alongside some of the people who are already doing it. That's a great way in, and you can learn by doing it.
Yeah, Ben's answer was definitely better than mine. I agree with that. I know. No, honestly, if you can find someone to pair with, if you can find the support within your current role, I think that's a really good way as well. So we've covered CI/CD. Do you use Multicloud? Have you ever implemented and managed that? If so, how does it work? I've used Terraform to manage that. I've never used Multicloud. So per project,
yeah.
If you're using AWS, if you're using GCP, you'll use all the services. That we will possibly integrate with other services, but not a cloud, like not a different cloud platform. As an example, you could use an auth provider that's outside of the cloud platform that you're using, and you'd integrate with that. So for instance, Auth0 is a really popular one, but we wouldn't. I've never been in a case where we're provisioning servers in both AWS and GCP, for instance.
Yeah, it sounds like I don't know if you're trying to do that or not. I'd love to hear about it if you are. I've only ever heard of one or two companies that have done it, and actually it feels a little bit to me like overkill. You've got to have a really good reason to do multi-cloud. If you're interested, I did hear of one of our clients that was going to do something called multiple cloud. I have no idea how they managed it, but essentially they wanted multi-cloud is like using services from one and other services from somewhere else, because Amazon might have a good machine learning service, but Microsoft have got better databases, whatever. And so that's kind of what I understand multi-cloud. But what this client we were talking about was multiple cloud, where it's just have a complete copy of their infrastructure in Google and a complete copy in Microsoft, because if they were having problems with one, they could just use the other. It's really complicated. I've never been involved in it. I've definitely never used Terraform to do it.
Yeah, I mean, the only situation I think of is a client's moving from one cloud provider to another. So they might be, have started off in one and decided that another option is better. So there's a transition period, but never actively maintaining both at the same time.
Do you think cloud engineers will replace backend engineers?
What are your thoughts, Ben?
I don't think they will. Some people don't like working in the front end. People want to be, have the really specific knowledge of a specific thing and be really good at that, and not have this so some people say full stack engineer is like jack of all trades, master of none, which I think is I wouldn't like to be described as that, but I know some people do say that, and so some people want to be an expert. And also, there's so many organizations out there. As consultants, we're finding organizations using such outdated practices that there's always going to be somewhere where you can be just a back-end engineer. Just whether if that's what you want to do, then do it. There's jobs out there. If not,
yeah, I agree with that. How is the interview for cloud developer? Do we need to show our projects if we were not working as cloud developer? What are employers looking for? I think it's, again, it really depends on the place. I mean, just as example, the interview process at Infinity Works is very much, what one interview was just discussing the architecture of a project that you worked on. So essentially just thinking about the entire system and how the infrastructure connects and how the services interact with each other. So yeah, I think system design is, I mean, I wouldn't say go too heavy on it, but system design is pretty interesting and useful. You don't necessarily have to show projects, but if you've had experience working on any, inevitably, if you worked on a project that uses cloud infrastructure, that would be something good to talk about. If you hadn't had the opportunity to work on a project that uses cloud infrastructure, I think it's worthwhile just creating a free account and just playing around, and then from there you can talk about your experiences. But again, it really depends. There's not like a kind of set interview process for a cloud, but it would be more just seeing if you've had experience with the tools that a cloud engineer would be using.
So if you're an inexperienced person and you're applying for a job, the person who's interviewing you understands your level of experience. What I'm looking for when I'm interviewing an inexperienced person is someone who's really enthusiastic, upbeat, positive, and sort of showing an interest and demonstrating that they are interested and are going to learn and want to learn. So if you're not experienced as a cloud engineer and you want to be one, you kind of, that's the level you're going to be applying for. The interviewer understands that, and especially certainly at InfinityWorks, that's kind of the sort of thing we're looking for, is like, be enthusiastic. It's great if you can say, this is something I'm interested in and this is what I've done to kind of learn about that. We don't want you to be an expert, but that shows that you're kind of really interested in it and you're going to make the effort to learn.
Are you able to share any specific examples, sort of issues you have when interfacing with backend engineers, and what sort of ideas do you share to overcome them? I mean, so this, I guess, is more a question of in the past, because I mean, again, as we're kind of discussing, that on our at InfinityWorks, everyone's kind of a well-rounded kind of engineer, in the sense of we work with both front end and back end. But in terms of, I mean, I've definitely worked on projects where we were initially brought in to be responsible for the front end, and there was another team who was working on the back end, and there were delays in the back end being finished, which obviously held up the kind of the release of the application. And again, like this is why it is quite tricky when specializations are separated, because essentially you're relying on different teams with different timelines. And it's not an easy problem to fix. I mean, yeah, it's all well like us saying, yeah, become like a well-rounded full stack engineer, but the realities are that there are a lot of companies, a lot of teams that are separated. And again, I mean, I guess it's about communicating clearly with other teams in terms of working out their timelines, and you can kind of, if there are going to be delays to the back end, say, you can at least kind of write contracts for what the back end will carry out, so that you can at least continue your front end work. So for an API, you can say, okay, we have this contract where we're expecting to receive this data from the back end, and the back end is promising to fulfill this, and at some point you will then plug in that endpoint, as an example. But yeah.
Okay, let's have a look at the next one. There's loads of questions, James.
We should probably be a bit.
I don't mind staying on chatting if people want to chat. But so, what does career progression from software engineer look like? Do recruiters know that cloud engineers are software engineers who also set up and maintain infrastructure? Well, what do recruiters know? That's a good question. You get different levels of recruiter. Internal recruiters are generally better than agency recruiters, in my experience. Some understand things, some don't. I saw a post on LinkedIn the other day about a recruiter who'd done a cloud architect certification. I'm sure they know what's going on. I don't know. It's difficult to say. All recruiters are different. What does career progression look like? So the typical levels in a career for a software engineer are, I think junior is not necessarily a politically correct term anymore, but junior engineer, mid-level engineer, senior engineer. I don't think those terms have been replaced. And then from there, you can go on to be an architect. You can go on to an architect's more responsible for kind of design and how systems operate together. There's like team leader roles or tech leader roles where you'll be responsible for a group of people and you'll kind of help them make the right decisions for what tech you're going to use. And then from that kind of there, you can be a manager of a department. There's principal engineers, which I think is a really interesting sounding role once you get past kind of senior and at that level, which is you're generally kind of working on like novel things. You kind of like, you see that there's a problem that multiple teams have got, and you'll come up with a solution or work with a team to solve that and share that and essentially like breaking new ground. I think that's a cool role. Yeah.
So, there are basically like quite a lot of options, and you can kind of to some extent choose which direction you want to go. It's just finding out what kind of future position appeals to you, whether it's being an architect or a tech lead. And then kind of working towards that. What do you think about cloud certifications? Do you think they improve your chances of getting hired or moving to cloud engineer role? So I have like there are two things I think about them. One is that part of it is you don't necessarily need one. I think they're useful to have. I've definitely learn a lot more about, say, the AWS one I took, in more depth than I necessarily would have. Mainly because you learn about a lot of services that you wouldn't necessarily have encountered. But at the same time, I definitely don't think I would need it to do my role, because essentially the services that you do end up using, you end up doing a deep dive into them anyway on the job. They are helpful. I mean, especially with a consultancy as well, because as a consultancy, you kind of want to prove that you have this expertise in cloud computing. So it does help to, it is basically a signal from one of the cloud platforms that what you're basically doing. And so in that respect, again, it might be a signal to a company that you have this certification to prove that you know what you're doing. But again, I know loads of people who are incredible cloud engineers who haven't done any of the certifications, and you very much don't need to. Yeah.
I'm not saying I'm an incredible cloud engineer, but I don't have any certifications yet. So yeah, I think like James says, if you've got one, it's going to be a differentiator between you and a candidate that doesn't have one. I personally wouldn't be going out and grabbing them. They are of strategic importance to companies. If you want to have a partnership with a cloud provider, as a company, you need to have a certain number of people that are certified, and that's the real value, in my opinion, of certificates. We can prove as a company that we've got a certain amount of expertise in the one cloud by saying we've got like 50% of our people are certified. You do learn loads of stuff in them. They are useful, but I wouldn't go following a cert over getting hands-on experience and doing a project with the cloud.
Yeah, definitely. How much of your day, week would you say you spend coding, and how much is researching, reading, discussing, designing? It depends. At the start of a project, we'll be doing a lot of So in terms of research and design, we'll do some technical research, but we also have UX and service designers, so kind of roles separate to us, and we'll kind of both facilitate the work, like help each other. So we'll inform the service and UX design in terms of what's technically possible, and UX and service design will also inform what solutions we might need to provide, because depending on the UX journey, we might need to implement different technical solutions. And then, I mean, a lot of time is coding, but having said that, it's a continuous process. We'll be coding, questions will arise. I'm constantly posting in our chat being like, I've encountered this consideration. What do we think would be a good way going forward? These are my initial thoughts. And then we'll set up a call to discuss that. And then that might involve another conversation with UX and service design to be like, look, given what you've told us, this makes this part of the flow a bit tricky. Is this locked in? There's flexibility. So it's a continuous iterative process.
There's some research been done around how much time people spend writing code and reading it, which I can't remember the exact value, but you'll find it on Google, although that's not necessarily the same thing. One thing I just was going to add was, like, the further on in your career you go, the more time you spend talking about things, because I kind of float around the team a lot, going and working with different people, asking them, like, trying to help out essentially when people get stuck with things. So there's a lot more discussing involved in that than there is writing code. But yeah, I'm going to whiz through the next one. What type of automated tests do you use BDD approach? I don't use a BDD approach. We as a team don't use BDD approach. What type of automated tests? We're using Jest to write unit and integration tests. We don't really do any end-to-end testing because it's a bit of a nightmare in microservice world, but there are people doing something called consumer-driven contract testing, which are relatively new approach to testing that have come around with microservices, which are interested, should read about those. I can recommend a project for learning about code. Cool. There's a project there if anyone wants it. Cloud resume challenge.dev.
So I think these are all.
This is Kimberly. What are you saying, Kimberly? Try to answer them, but we're running out of time.
Yeah, no, I just saw that there was loads to come through, so I said, around any from this point on, you don't have to answer depending on time, because I'm aware that we're nearly at 1 o'clock, so it's up to you.
I mean, I'm having fun. No, we'll have to get on to some point, so I'm fine. Whatever. What about you, James?
Yeah, if people want to ask more questions. I mean, there's one more further down, which is what's the difference between cloud developer and DevOps developer? Yeah, that is a good question because the lines kind of blur a little bit. Again, DevOps, again, I guess it's a kind of thing of like jack of all trades where we do provision infrastructure, we do deploy, and we do manage our CI/CD. But it's not necessarily our specialty in the sense of for a DevOps engineer, that's exclusively what they do. Whereas we're not necessarily, I guess a DevOps engineer is more managing the infrastructure kind of from an overview perspective, whereas we're kind of managing the infrastructure for our specific feature, let's say. And again, the lines are blurred because a lot of what we do would be similar to what part of what a DevOps engineer does, but a DevOps engineer would just encompass a lot more focus on the infrastructure side of things.
So DevOps engineer is quite a controversial topic if you spend any time in the industry. DevOps. So here's my hot take on it. The DevOps is supposed to be a culture where the development team are responsible for operating and kind of maintaining the software in production. Having a DevOps developer, it kind of, well, it doesn't necessarily, but it sort of contradicts that, because you've now got a separate person and sometimes a separate team that are responsible for ops. So you can't be DevOps. The developers can't be responsible for the infrastructure if you've got a separate team doing the DevOps bit. So yeah, what was the original question? I got lost in my rant.
I mean, I guess the idea is often a DevOps engineer like sits within the team. Like in places where I've worked, where we've had a DevOps like engineer, like specifically, it's they sit in their team and they're kind of like the bridge between the code and the deployment.
So that's definitely the right way to do it, is to have a DevOps engineer that works with teams to make sure the teams are doing DevOps in a good way. If you see a DevOps team, or like that DevOps engineer should probably also really be doing some of the dev, shouldn't they? In my opinion, like, because there's not enough work to do DevOps 5 days a week, 8 hours a day.
Controversial. But yeah. So I mean, again, like there's a blurred line. Again, it's kind of like what's the backend engineer and cloud engineer. Again, like there's overlap.
Lots of overlap, yeah. Someone, I think this is going back to the original like multi-cloud. Yes, okay. Sorry, we missed these because we're dead slow on like answering all the questions. But you deploy on AWS. If that goes down, you can switch and redeploy on GCP. Yeah. So definitely, that's a possibility. In my opinion, the chances of that are relatively slim, and the cost of being able to deal with that is going to be pretty big. So it all depends on what type of business you are, like what would the impact be of that happening? It does happen. There's been some pretty major outages from all the cloud providers. You can find those on Google. They're quite good fun if you want to learn about how some absolute mega global corporation has just taken down half of the PlayStation network or Xbox Live or whatever. Jack of all trades, master of none. But better.
I think these are all. I think these are all just like comments now. I think we've answered all the questions. I mean, if anyone has anything else, feel free to shout out. But otherwise, I think we've.
CTO is a rule too. Are you a CTO, Damon? Have we missed you out? What's the difference between cloud DevOps? Sorry, okay, you've done that one. Yeah, okay, cool. I'm catching up. Someone's got to go back to work. Me too. Cool. That was fun. Thanks for having me.
Yeah, thanks for having us. And yeah.